Okay, so looking at page 671, number 4. It says the denominator of a fraction is 2 more than the numerator. So I went with the one that was less and I let n equal the numerator. So then n plus 2 is equal to the denominator. Okay, and then it says the sum of the fraction. So the fraction then would be n over n plus 2. The sum of the fraction and its reciprocal. Okay, so we know we're summing. Now we're taking the reciprocal of that fraction. Is means equals 34 over 15. Okay, so it's a little bit more complex because we need to find our LCD. First, we have to know that the domain is n cannot be 0 and n cannot be -2. So that's important. So I'm always going to write that down. But then I'm also going to consider my LCD. So my LCD is going to have an n plus 2 in it. It's going to have an n, and it's also going to have 15. So I'm going to put the 15n over here. Okay, now we are going to clear the fractions by multiplying the whole thing by the LCD. Okay, so if I multiply it to the first one, the n plus 2's are going to cancel, and I'll get 15n squared. And if I multiply it to the second term, the n's are going to cancel, and I'm going to get plus 15 times n plus 2 quantity squared, because there'd be 2 of them that you'd be multiplying. And in the last one, the 15's are going to cancel, and so I'll get 34, and I'm going to multiply n times n plus 2, and I'll get n squared plus 2n. Okay, so let me stand up so I can see this a little better. All right, so now I need to FOIL this. So I'm going to get 15n squared plus 15 times square the first term, double the inside product, so 2 times n, and then double it, and then square the last term, equals, and I'm going to distribute my 34. So 34n squared plus 68n. All right, we're getting there. All right, so now I've got to distribute the 15. So yes, it's long and involved, but not anything we can't do. So I distribute my 15. And I'm noticing already that it's a quadratic equation. How do I notice that? Because that exponent of 2 tells me that it's quadratic. So I know I'm going to be setting it equal to 0 and solving by factoring. Okay, so let's combine the like terms here, and we get 30n squared plus 60n plus 60 equals 34n squared plus 68n. Okay, so I know that it's quadratic. I need to get it set equal to 0. So I'm going to bring the 30n squared over. Actually, let's just bring these over because it's easier. So I'm going to subtract 34n squared from both sides. That's going to go away. I'm going to subtract 68n over here. And I'm going to get -4n squared minus 8n plus 60 equals 0. Okay, so now we've got to be really careful. We really don't want to deal with a negative square term. And we should hopefully see that there's a GCF. So I'm going to divide and simplify. I'm going to divide out the GCF to every term to simplify the equation, and I'll get n squared plus 2n minus 15 equals 0. Okay, so now I'm going to solve by factoring. So I need the factors of 15, -15, that add to 2. So that's going to be n plus 5 and n minus 3. All right, so I'm getting closer. Set each one equal to 0, so n equals -5 and n equals 3. All right, so if n is 3, then the denominator would be 3/5. And n can't be -5, could it? Because if it's -5, I would get -5 over -3, which would give me 5/3, and the denominator would not be 2 greater than the numerator. So n cannot be -5, so it would have to be 3/5. Okay? So hopefully that explanation helped you. I know that was a little bit more long and involved, but it's some great factoring practice. Have a great night.